Hi everyone, and welcome to a bonus session of Making Sense of Mechanics. This is just going to be a very short video where I focus on Newton's third law. Now it's a very simple law, but it's so often misunderstood, which is quite frustrating. So we're just going to make it absolutely clear and precise what Newton's law means, his third law here, because that will be important in future sessions. You'll notice I'm invisible for this one. I'm not on screen. Just going to keep it very simple. I can put that red t-shirt in the wash, but I promise I'll be back on screen again next time. Now, one of the most common and traditional statements of Newton's third law is along the lines of, to every action, there's an equal and opposite reaction. And I'm just not a fan of that, I have to be honest. I can't say it's wrong. I just say it's a very unhelpful phrasing. It gives you no insight into what the mechanical principle actually is. And we're going to begin with a non-example. What is it not saying? So I've got this force diagram where there's a book resting on a table and two forces have been drawn that act on that book. There's a normal reaction and there's a weight force. Now, I'll agree, if this book is not moving, if it's in equilibrium, just resting on the table, then those forces R and W will be equal in magnitude, and they are opposite in direction. But that is not the equal and opposite that Newton's third law is talking about. So I think that's quite a common misunderstanding. People may be tempted to say R equals W because of Newton's third law. They're equal and they're opposite. Now that's not true. So let's take a really clear, careful look at what the third law does mean. So this third law, it does talk about equal and opposite forces. That's absolutely true. And some people talk about ideas of forces being in pairs, or almost like a buy one, get one free with forces. But there's a really simple, precise way to get it correct. And I'm going to bring you back to my four-part description for a force. We first saw this in video 1.2. If you want to go back and review forces, we have this phrasing. There is a type of force acting in some direction on object A due to object B. So if you remember my previous diagram, I could say there is a normal reaction force acting vertically upwards on the book due to the table. So we already have that phrase, that careful description for forces. Well, then Newton's third law implies a very simple alteration to that phrasing. It would say there is a same type of force, that hasn't changed, acting in the opposite direction on object B due to object A. And if you make those changes in red, then you've completely correctly interpreted Newton's third law for any given force. So the type of force does not change. What changes is the direction. It's the opposite direction geometrically, and the cause and effect objects have changed places. It's now acting on object B due to object A. Okay, so essentially the force acts on both objects due to their interaction together. So let's look at this book again and we'll run through that phrase. So I'm going to focus on the normal reaction force. There is a normal reaction force acting vertically upwards on the book due to the table. Now we apply Newton's third law, we apply that principle, and that will change to say there is a normal reaction force acting downwards on the table due to the book. Now if you're wondering why that force isn't shown in the diagram, I'll remind you of the principle from our last video where we only show the forces acting on one specific object. So this force diagram is showing the forces acting on the book. The partner of that force, as it were, from Newton's third law, is a force acting on the table. And this diagram is not showing forces that act on the table. So just because these forces exist doesn't mean we have to show them in one of our diagrams. And we can apply the same principle to the weight force. So let's go through that. Currently, there is a weight force acting vertically downwards on the book due to the Earth. We apply the changes of Newton's third law. There is a weight force acting upwards on the Earth due to the book. Okay, no matter how strange that sounds, it's absolutely true that gravitational interaction between two objects, the Earth exerts a force on the book exerts an equal force, equal in magnitude, an equal force on the Earth. They each exert a force on the other. Now, I did say this would be a very short video, and I'm true to my word. That's the only point I wanted to make here. One single but crucial point, which is this understanding of Newton's third law. Now, this will be applied later on when we have questions where there's boxes stacked on top of other boxes, or there's a string passing over a pulley, or there's all kinds of situations where we'll need to apply this law. So it's best that we get it super clear and precise up front, and then we're ready for the future. So I'll leave this slide with you, reminding you of the changes that you make to interpret what Newton's third law tells us about the so-called equal and opposite force. I'll see you next time.